Hello, good morning to everybody. Hello student, how are you? I hope you all are happy, healthy and fine at home. What did we discuss yesterday? Yesterday we discussed about the general electrophilic addition to carbon-carbon triple bond, and it involved two steps. Step number 1, formation of the vinylic carbocation, and number 2, attachment of the base, that is X minus. So these are the things I think we have seen in the previous lecture. Today what we are going to learn, that is the addition of reaction of alkynes. Addition reactions of alkynes. Addition reactions of alkynes, and as we know that alkynes containing as a carbon-carbon triple bond in the introductory part, we already learned about that one. Then let us see here addition of halogen. Addition reaction of alkyne. In that first one we are going to learn addition of halogens. Addition of halogens means halogenation, that is called as a halogenation reaction, right? This is a halogenation reaction we are learning. Addition of halogens, halogenation reaction. Now addition of halogen reaction to alkyne proceed through formation of violinic halide intermediate and not the cyclic halonium ion as in case of the alkene. So in case of the alkene, when the halogenation takes place, there is a formation of the three-membered cyclic halonium ion. If bromine is there, cyclic bromonium ion. If chlorine is there, cyclic chloronium ion. So that type of the three-membered ring is not forming in this case. Here the addition of bromine to propene. For example, addition of bromine to propine, right? Propine is a starting material we are considering in this case, and as we know the example of this CH3 C triple bond CH. Look at here acetylic proton. I already told you that these acetylic proton are highly acidic in nature because it is attached to the sp carbon atom, and therefore it is a highly acidic in nature. And now in the first one, Br2, when we are adding Br2 in presence of CCl4 carbon tetrachloride, what the product we are actually it consumes the 2 moles of the bromine, and we are getting finally the structure is this one, CH3, then CBr, here Br, then CBrH, and this Br, 4 Brs are there, numbering starting from this side 1, 2, 3, and therefore at one position there are the 2 bromine atom, and therefore 1, 1, again at 2 position there is again 2 bromine atom, and therefore we can call it as a 2, 2. So total becomes as a 4, therefore tetra 3 carbon atom in the straight chain, therefore prop, and last suffix is a ane, propane. So that is a compound we are getting over here. Now let us look at the mechanism, how the mechanism takes place over here. Look at the mechanism. Starting compound is this one, CH3, then C triple bond CH, that will be treated, and as we know that bromine atom get polarized like this. It first atom gets plus delta charge, second atom get minus delta charge. This type of the polarization only shown by the halide group. And now what is going to happen, as we know that triple bond, it acts as a source of electron and it is going to attack on this bromine atom. Another bromine get depart like this, and you are going to get the first step is, as we know that it is a slow step, and slow step is known as rate determining step, RDS. This one RDS step, and this step, and according to that what do you get here? CH3, then C double bond C, one hydrogen atom already there and one Br attached, we can write here Br, right? Br. And now when this double bond, this bond moving forming as a bond with this bromine, what kind of the charge present on that carbon atom? This carbon atom carry the positive charge, or this carbon atom has positive charge, and this carbon, there is a carbon carbon double bond and the positive charge present on that carbon. This type of the species is known as valenic valenic cation. This one, this is a valenic cation present over there in the first step. And now this valenic cation is a very stable one. In the, this is a step number first. In step number first, this type of the valenic cation is formed, and that valenic cation, and here look at here one Br minus, that is a living group present over there. And now in the step number second, in the step number second, what is happening? In the step number second, CH3 C double bond C, here is a bromine atom, hydrogen atom, this is a positive charge. Now this another bromine atom which is negatively in charge, it is going to attack on the valenic carbon atom. So this is going to attack on this carbon atom, and we are going to get the product like this. This one CH, what we can call it as CH3, then C double bond C, one Br is here, H is there, and another Br which is coming from there, it is attack over there. Now still there is a 2 moles get consumed. So how this 2 mole get consumed? Let us see here. Now in a step number third, we can call it as step number third. Here what is happening? This one CH3 again CH, one Br double bond Br and this CH. Still there is a carbon carbon double bond, still it is a unsaturated compound. Again second mole of that bromine, plus delta charge here, minus delta charge, it is going to consume. Again look at here, this double bond is attacking over there, and then Br departs, so that you are going to get here CH3, then another one CH, not here is a one hydrogen atom is a, let us see here, make the correction, there is no hydrogen atom at all. Here is a Br, then double bond, not double bond, one double bond is a shifted forming as a one Br atom here, one H already there, one Br. Now there is a positive charge, that is carbocation formed there. This is again halide carbocation. Carbocation intermediate is formed in this case. In the next step, step number fourth, you can call it as a step number fourth. What is happening in the step number fourth? One Br from this Br minus till there, and that in the next one, what is happening? CH3, then C Br positive charge, then C, here is a bromine atom, here also as a bromine atom, hydrogen atom, and plus Br minus over there, and that Br minus further attack on attack on the carbocation. This negative charge is now attacking on this carbon atom, and finally you are going to get CH3, then C, Br, here is a Br, then C, Br, and one hydrogen atom over there, and therefore in this way we can write the mechanism of this. So first step only as a rate determining step, whereas second step is a very fast step, and we are going to get this. Now let us look at as the next one, addition of halogen acids. Now is a addition of halogen acids. Second reaction we are discussing here, addition of second B you can call it, addition of halogen acids. That is a addition of halogen acids. Halogen acids, as we know that HX, right? These halogen acids again in general we know that. Let us see again here CH3, then C triple bond C. Example we are talking about H. This is a propane we are considering. General reaction propane, that will be again treated with 2 moles of HBr, you can call it HBr, and the formation of the product will be this one CH3, then C, then here Br, again Br over here, and this CH3. Look at CH3, right? Now the name of this compound 1, 2, 3. Number you can give from number, right hand side or left hand side. It never change the position, because that bromine atom in the middle one. So you can give the numbering either right hand side or the left hand side. It doesn't matter. Now at 2 position, look at this type of the position is called as a geminal position. Both the halides are present in same carbon atom. This position is called as a geminal position. Geminal. So geminal is a word. Geminal halide you can call it as a geminal halide, means both the halides are present on the same carbon atom, and that's why it is known as geminal halide. So the IUPAC name of this compound, so 2,2, because both the bromine atom present at the second carbon atom, and therefore 2 is there, therefore we can call it as a dibromopropane. This is the IUPAC name of this compound, 2,2-dibromopropane. Now let us look at as a mechanism of this, and as we know that mechanism is a language of the organic chemistry. If you know the mechanism, you can able to write that one. Now let us see here, how do you show the mechanism here? See this reaction carefully, observe this reaction carefully. What do you see? The 2 mole consume across the carbon-carbon triple bond, because there are triple bond. Among the triple bond, 1 is a sigma bond and 2 are the pi bond, and that's why to form breaking as a 2 pi and 2 pi bond, there is a formation of the 4 sigma bonds over there, and the molecule is finally converted into as a saturated one. Now let us see mechanism over here. CH3, then C triple bond H, that is a propane, that will be first molecule HBr adding over there. So in the first step is a rate determining step, which is a slower one. This, and as we know that HBr, a hydrogen atom get partial positive charge, bromine atom get partial negative charge, because halide has a tendency to attract the electron toward themselves, and therefore they get the always minus delta charge in this type when they form the bond with the hydrogen atom. Now this double bond moving, and there is a transfer of hydrogen from this acidic reagent to the alkyne. So what do you get over here? You are going to get, and the reaction here taking place according to the Markovnikov's rule. And as we know that Markovnikov's statement, the rule, it is stated that in an addition reaction, negative part of the reagent attached to those carbon which carries less number of hydrogen atom. If you compare these two hydrogen atom, middle hydrogen atom does not carry hydrogen atom or does not contain hydrogen, but terminal carbon atom, there is a one, it contain one hydrogen atom, or it does have it has one hydrogen atom, and therefore we are going to get here C double bond, C one hydrogen atom here and another this hydrogen atom which is coming from the acid. And now here when this double bond moving that side, what kind of the charge present on that carbon atom? It carries positive charge, and that type of the species we know that it is a carbocation or the carbonium ion. And here the Br minus, which is the leaving group. Now in the step numbers, this is, you can call it as a step number first, and because it involves, this mechanism involves two steps. So step number first, and this is a step number second. In the step number second, what is happening here? CH3, then C double bond, CH, DCH, positive charge over there, then Br minus. Now this Br minus is attacking on that carbon atom, and the resulting compound obtained will be this one, C Br, then double bond, this we can call it as a CH2, and this type of the halide is called as a vanillyl halide. Vanillyl halide we can call it. Vanillyl halide further consume the another moles of HBr, and we are going to get the product. Let us see over here. Here step number third, you can call it over here. Now here CH3, then C double bond, CH2, Br, still there is a carbon-carbon double bond, means this compound is unsaturated in nature, then treated with another molecule of hydrogen bromide. As we know that hydrogen get partial positive charge, bromine get partial negative charge. This double bond moving like this, and this there is a heterolytically bond broken here, and we are going to get here CH3, then C Br minus, and then this CH2 already there, CH2, and one H from here, that becomes as a CH3. I am writing here only, you understood this one. And now when this double bond moving here, the positive charge come on it and Br minus as it is, right? And now in the step number third, what is happening? There is a step number third. Look at this mechanism carefully. Then what is going to happen here? This intermediate, this is a carbocation again. This is a carbocation. Carbocation, it is short-lived intermediate form in this case. And now CH3, then C Br, CH3, positive charge over there, and this Br minus. Now this Br minus attacking on this carbocation, and we are going to get the final product C here Br, another Br, and this CS3, which is known as 2,2 because 1,2 dibromopropane. This is a reaction. I think 2 reaction we have seen over here. So remaining reaction we will see tomorrow. Let us stop today here. Thank you. Have a nice day.